Hello and welcome to our lesson on radical expressions, rationalizing the denominator. First, let's talk a definition. A radical expression, so no equal sign, combines numbers, variables, and radicals with an operation. So we're talking addition, subtraction, multiplication, or division, and again, there is absolutely no equal sign. Here are some examples that have radical expressions in them. Notice that there's no radical on a denominator. You can make them into fractions by simply putting them over 1. Again, same thing here, no radicals in the denominator. No radicals in the denominator. There is one here, however, if you take the square root of m squared, you would get 52 plus m, and that would be your new denominator. So again, no radicals in the denominator. These are rational expressions. But what happens if you don't have a rational expression? An expression is irrational if the denominator is not rational. So take a look. You can't put that over 1, it's a radical sign. You can't put that over, can't put it over either. Those are all radical signs, and their location is what clues you off that if you have a radical in the denominator position, you do not have a rational expression. You're going to have to use multiplication to make it a rational expression. And how do you do that? Well, you multiply the denominator by the conjugate. And the conjugate means you have the same numbers and variables, the same terms, and the only thing that you do is flip the sign in between the two terms. So let's say you had x plus radical 3. A conjugate would be x minus radical 3. I have the exact same terms, and the only thing that changed was I flipped the signs. That's called a conjugate. Remember, you must apply the rules of equality to the fraction. So whatever you do to the bottom or the denominator, you must, absolutely must do the same thing to the top of the fraction, the numerator. Treat it as a normal multiplication of radicals, and remember to simplify whenever you can. Why don't we try one? Let's look. We have 3x minus 54. Okay, if I have this original fraction of 2x over 3x minus radical 54. First thing I need to do is find the conjugate of the expression in the denominator position. Remember, a conjugate means that you write the exact same terms. So I have 3x and radical 54, and the only thing I change is from the negative sign that's right there, I must switch it to a positive. Now I've created the conjugate. Step 2, once I do that, I have to now multiply it by the numerator as well. So I'm going to take my 2x over 3x minus radical 54 and multiply it by that denominator conjugate. So I'm multiplying 3x plus radical 54, and I'm doing it by the denominator and the numerator. The exact same conjugate gets multiplied by the denominator and the numerator. Okay, so we need to go ahead and multiply it out or FOIL it out. So we are multiplying both the top and the bottom, the numerator and the denominator, by 3x minus 54 on the top and 3x minus 54 on the bottom. But actually it's 3x plus because we're using conjugate, right? We're doing the same terms, flip the sign. Now when we do that, let's do the numerator first, a little easier. It's just distribution. So on the numerator, you're going to have 2x times 3x, so you're going to have 6x squared. Then you're going to have 2x times radical 54. And they're both positive numbers, so it's going to be a positive 2x radical 54. Now on the bottom, you're going to have 3x times 3x, which is 9x squared. And then you're going to have 3x times radical 54, and it's positive 3x radical 54. You're going to have a negative radical 54 times 3x. That makes it a negative 3x radical 54. And then you're going to have to multiply the last terms, which is radical 54 times radical 54. And notice one is a negative and one is a positive, so you have to have a negative radical 2,916. And that's all denominator position. Take a look right here, though. Something lovely happens exact same terms, different signs. What happens when you have a positive 3x radical 54 and a negative 3x radical 54? They cancel out. Gone. You have two terms gone from the denominator. Now what we need to do is focus on reducing anything or simplifying anything if we can. 54 is not fully reduced. So that would be 9 times 6, 3 times 3, and 2 times 3. That means that we have a pair of 3's and a 6 that stays back under the radical because you're multiplying 2 times 3. So on the numerator, you're going to have 6x squared plus, and you're multiplying the original 2 times the 3, so that's 6. And then we have x. And instead of the 54 now, it's just the 2 times 3, which is the 6 under the radical. Here, we've got radical 2916. If you remember, we created that by multiplying the 54 by 54. So it turns out that 2916 is a perfect square, and the square root of that is back to the 54. So on the bottom, the denominator, you actually have 9x squared minus 54. Now, this is as far as we can go. We're not going to pull anything out or reduce anything as far as, hey, let's take a 6 out of the top and a 3 out of the bottom. No, don't worry about that. This is where we're going to stop because all I wanted you to see is how you would rationalize the denominator. Let's try another one. We have 6x plus radical 20y squared. That means that we have to multiply it by 6x minus radical 20y squared. I just found my conjugate. Remember, the conjugate means that you have the exact same terms but different signs. Same 6, let's get rid of the x, same 6, and you have 20y squared, and the only thing that's different is you've got a plus and a minus. Now with step 2, we're going to go ahead and multiply it. So we are multiplying it by the exact same with the different signs, so it's 6 minus radical 20y squared, and then 6 minus radical 20y squared. Let's do the top first, the numerator. All we're doing is a distribution. So 25y times 6. So you're going to take 25 and you're going to multiply it by 6. And when you do that, you're going to get 150y. And then you're going to multiply 25y times the radical. Because it's a negative, you're going to end up with negative 25y radical 20y squared. On the bottom, we have a FOIL. Let's remember the shortcut though. Do you remember when we multiplied the exact same radical by the exact same radical? All it ended up doing was canceling out the radical, and you got the number with the variable and the exponent. It squared it, and then you have to take the square root of it. So in essence, the radical sign just cancels itself out. You do, however, have to actually multiply 6 times 6. You're going to get a brand new number. You get 36. And because this was a positive times a negative, you get a negative. And once you square them, and then take the square root of them, you end right back up with 20y squared. Okay, so let's continue on. We've got 150y minus 25y radical 20y squared. We got that when we did our multiplication. And we also got 36 minus 20y squared. Because remember, our inside and outside terms canceled, and the radical disappeared after we squared it and unsquared it. Now let's take a look and see, what can we do? Well, there seems to be something right there that could be reduced. So we're going to take 20 and y squared, and we're going to reduce them. See if we can break them down to prime factors so that we can reduce the whole radical. We have 5 times 4, and then 2 times 2. Pair of 2's. 1, 5, he goes back in. Now y squared really means that we have y times y. We have a pair of y's. So actually we can change that into 150y minus 25y times 2y, and then our radical of 5 that was left over. That's what we can do to the numerator. We're going to leave the denominator as it stands, so that's 36 minus 20y squared, because there's nothing we could do to reduce it. So here we go. We could multiply this out, and we're going to go ahead and do that. 150y minus, and now we're going to multiply the 25y minus 2y, and we're going to get negative 50y squared, because we're actually adding exponents instead of multiplying them, even though it said to multiply. And we still have our radical 5. And then this is all over 36 minus 20y squared. Are there any more like terms to combine? No. Is there anything we can break down any further? Nope, because that radical 5 is fully broken down. So that means that this is our rationalized denominator answer. Let's try one more example. First step is we need to find the conjugate. So let's look at the denominator. What can we do to make it a conjugate again? We can rewrite the terms of 2 and 3 radical 5x, and we flip the sign. It's a negative originally, so we have to make it a positive. So once we do that, we're going to do multiplication, and we're going to multiply 2 plus 3x, 3 radical 5x. So we're going to do 2 plus 3 radical 5x. If we do it to the numerator, you got to do it to the denominator. Keep the fraction equal. And then when we do that, we're looking at FOIL. So 6 times 2 is 12. 6 times 3 radical 5x is going to be a positive 18 radical 5x. And then we're going to have to take 4 radical x squared times 2. Still positive. So we have positive 8 radical x squared. And then we're going to take x squared times the last term, which is 3 radical 5x. So that's going to be another positive. 4 times 3 is 12. And x squared times 5x is going to be 5x cubed. And this is all going to be over 2 times 2 is 4. And remember, when we multiply the inside and the outside, they're going to end up canceling out. So really, all we end up doing is squaring this guy, squaring this, and then taking it back out of the radical. So it's really just a repeat rewrite of negative 3 radical 5x. And if we want, we can go ahead and write it all out so you make sure you see how it's being done. So let's take 2 times 2 and then 2 times 3 times radical 5x, and that's going to be a positive 6 radical 5x. Then we're going to take a negative 3 radical 5x times a positive 2. It's going to make it a negative 6 radical 5x. And then we're going to multiply it for the last term, which is going to make it a negative. 3 times 3 is 9. And radical 5 times radical 5x, both of them x's, are 25x squared. So we've got all our terms. Now, those middle terms, you see how I didn't write them here? It's because they ended up canceling each other out. Let's go back and look. You have a positive 6 radical 5x and a negative 6 radical 5x. You see those? They're exactly the same with the sign flip, which means they will zero themselves out, which is why in the next one we didn't have to write it. However, if we look at this, we need to make sure that we fully simplify anything under the radical. Is 5x fully simplified? Yes, 5's prime and x doesn't have a pair to pull out. Is x squared fully simplified? No, x squared means x times x, so we have a pair to pull out. So on our numerator we can write 12 plus, nothing to simplify here, but we can take out an x. So our original 8 right here times the x that we took out is 5x cubed squared. 5x cubed squared is not simplified. 5 is a prime number. We can't pull him out. But if we have x times x times x, we've got a pair of x's here. We can pull one set out. So we're going to have the original 12 that was already there. Pull out a set of x's, and all that you're left with is that 5 because it's prime and that lonely x. Now look at the bottom. I've got 25x squared. Those are primes. Those are not primes. Those are perfect squares. We can pull out something from 25 because 5 times 5, we've got a pair. So we can have 4 minus 9 times 5, and then you've got an x squared. What's the square root of x squared? It's x. So here we go. We've got everything reduced, simplified as far as it can go. Let's see if we can do any combining of like terms. I've got a 5x, 18 of them in fact, radical 5x, and I've got another 12 of the radical 5x. Are those like terms? Comes close, but it turns out not, because look, you've got an x there and an x there missing. Even though we have a 5x radical here and 5x radical here, what we'd need to do is have a 12x with an 18x. So it turns out those are not like terms. So your numerator is going to stay how it is, 12 plus 18 radical 5x plus 8x plus 12x radical 5x. Now on the denominator, PEMDAS says you do multiplication first. So we're going to multiply negative 9 times 5. So we have 4 minus 45x. Now your last step, go back and double check all the work. Make sure that you did all your multiplication correctly, make sure that you factor treed correctly, and make sure that you combined any like terms correctly. If you go back and double check, it turns out that this should be the correct answer. As a quick review, a radical expression cannot, absolutely not, stay in the denominator of a fraction. You multiply the radical denominator term by its conjugate. And remember, the conjugate means flip your sign. Keep the same terms. So if I have x plus radical 3, the conjugate is x minus radical 3. Same terms, just a sign flip. That's what a conjugate is. Multiply the numerator by the same conjugate as you did with the denominator, and be sure to reduce any radicands if you can. And always make sure to go back and double check. And that's it for our lesson on radical expressions, rationalizing the denominator.